Over the last couple of lectures, right, we've seen several new definitions and a lot of new notation. Now, like most mathematical notation, these new tools are useful when we really need to be precise about what we're saying. However, in practice, using English phrases is still very common, and it's common for there to be multiple English sentences that are equivalent to a given logical sentence. Now, with that in mind, you need to be able to read an English statement and identify whether or not what it's describing is a universal statement or an existential statement. So I've got an example here of a universal statement and some equivalent English sentences. Now, all of the English versions have some things in common, right? They all have an English version of the predicate. Not always phrased the same, right? Some say greater than or equal to. This one down here at the end, right, says at least equal to. And they all have some version of the domain. And they all have some word like every or all or each that makes it clear that we're talking about every element of that domain. All right, so we've got a similar situation here with an existential statement. The English sentences all have an English version of the domain, an English version of the predicate, and again, some word that makes it clear that we aren't talking about the entire domain, something like some or at least, or down here in the last sentence, it can even be just a single word, single letter, right? Like a natural number rather than all or every natural number. All right, so I've got some examples here of English statements. And what I want to do is with these is twofold. I want to identify whether they're universal or existential. And then I want to rewrite them using more symbolic or mathematical notation. So if you're following along, go ahead and pause here and see if you can answer those questions for yourself. Then you can start the lecture back up and we'll go over them together. Okay, so the first thing I want to do is just characterize these, right? As existential versus universal. Okay, and try to disregard the math part, because right, you may be familiar with some of these things already. You may know, well, okay, it's not talking about everything, but try to just focus on the language as you're doing this, right? So this first sentence is talking about some, right? So I would make that an existential statement. The next one is talking about all. That's universal. Okay, here, this next one is a little tricky. It's talking about never. Okay, never is talking about something that happens all the time or in every instance or for every value of a variable. So I would put this in the universal category. Here there exists, so that's going to be existential. And here no natural numbers are negative. It's a statement about all natural numbers. So again, I would call this universal. All right, so let's see how we can write these using our for all and there exists notation. Okay, so for this one, the first one, I would say there exists a rectangle such that it's also a square. Now there's other ways you could do these, right? That's kind of the whole point of this lecture, is that there are multiple equivalent English phrases. You could have said there exists a rectangle such that the rectangle is a square, for example. Okay, even when we go into the symbolic version, sometimes there are acceptable variations. Okay, all differentiable functions are continuous. So I would say for every differentiable function f is continuous. Okay, so how about this one? The square of a real number is never negative. Okay, how are we going to do this? Well, I know we're talking about a universal statement, right? So I'm going to say for every x an element of the real numbers, right? X is not negative. Excuse me, the square is not negative. X squared is not less than 0. Okay, which is maybe a little awkward. We don't usually say not less than, right, with the less than with an arrow through it. So you could equivalently write this for all x an element of the real numbers, x squared is greater than or equal to 0. That's another equivalent way of saying not negative. Okay, how about the next one here? There exists a negative real number. Okay, there exists x an element of r such that x is less than 0. And finally, no natural numbers are negative. Okay, how are we going to do this? Well, here I really am I'm going to have to work at this a little. No natural numbers are negative. This would be equivalent to all natural numbers are not negative. And I would write this, right, for every x an element of the natural numbers, x is greater than or equal to 0. Okay, so you might be thinking, I started to cross some lines here with some of these. Some of these, it may have felt like it was easier to write them in terms of an existential statement. All right, couple lectures down the line here, we're going to talk about the negation of a universal statement and the negation of an existential statement. Right, and when we add those tools to our toolbox, you'll see sometimes there are more efficient ways of writing these things, right? But we'll circle back to that one in a couple of lectures down the road. So in the next lecture, we're going to continue this conversation of finding equivalent ways of reading a logical statement by adding a new type of statement to the mix, the so-called universal conditional statement.